about equivalence graphs. If you remember, they're like what's used for the theory of uninterpreted functions, and basically they store equivalent expressions as a data structure. And Egglog is a homegrown framework here based out of the Pulse Lab at UW that uses equivalence graphs to sort of be a framework for building compilers or transpilers. So they let you write your own domain here, like numbers, write some expressions. You can turn it into a graph, and then you have rewrite rules to like optimize it in some way and extract out the best program. So what we wanted to see is, could we take the best of both worlds? Basically, like, eGraphs are good for some things. They're really expressive. You can write whatever domain you want. You have control over schedules and rewrites. And SMT solvers, obviously, as we've learned, are also good for specialized domains where there are theories for them. So there's lots of ways you could try to combine these technologies. The route we took was basically, can we embed an SMT solver inside of Egglog? So Egglog is like the top level scheduling language, and then for certain rewrites or for certain algorithms, you might want to call into an SMT solver for specialized domain knowledge. On the left side here, this is like an SMT-lib example. On the right side this is Egglog code that does basically the same thing. So we can define uninterpreted functions, we can make calls, we can get a model, we can check if it's sat. And now we're gonna, and we built this on top of Egglog, but we didn't have to fork Egglog. Like, we could build this all as extensions, so that's kind of nice. It's like modular, so people who are already using Egglog could just pull this into their code without having to change anything. So we're gonna go now into like 4 different examples or demos.
Yeah, so our project is very example driven. We're not really trying to solve a very specific problem in SMT, but instead allow our users to use both SMT and Egglog to solve whatever problem they might want. So some goals for problems we'd like to solve are those that can't be done just in Egglog, or problems that can be done in Egglog, but it's very inefficient, for example, requiring exponential time to run rewrite rules. So one example of something that's hard to do in Egglog is factoring polynomials.
Can you pump the font size instead of white background? Command Shift P or something. And color. Boom. Oh.
Okay, so what this analysis does, which is written in Egglog SMT, so it uses both regular Egglog features and SMT features interleaved together, is it takes a polynomial written as a sum of monomials, and it factors it into a product of x minus a, where a is some rational number. And the reason we restrict this to be rational numbers is because those are much easier for Egglog to handle, and a lot of the time when you get into algebraic numbers, for example, the characterization of those is just based on them being the roots of polynomials. So your factorization may not be very useful if you allow algebraic numbers. And we also ignore complex numbers in this example. So for some examples, we have this constant polynomial, which is just 10. This will be rewritten by our example. It'll be rewritten to 10. We have this small rational example. X squared minus 1/4 will be rewritten to x minus 1/2 times x plus 1/2. This polynomial has algebraic roots, so it will not be rewritten, but in theory it would be equal to this. And the same for this complex polynomial. It won't be rewritten. And then we just have a larger rational example to showcase, powers of roots, so like multiplicity. So the main use of SMT here is to find roots. So we encode that we want to look for a root by saying, okay, x is equal to some integers p over q, and q needs to be not equal to 0, because if you allow dividing by 0, the SMT solver ends up just giving you whatever it wants. And then once we find those, we put them into a model, and we can then extract from that model to update the current factorization of the polynomial. And if it turns out that the model was not satisfiable, then if we have not found a number of roots equal to the degree of the polynomial, then we stop and we say, okay, we can't factor this with rational factors. Yeah, and then from there, once we found a root, it's possible that this root has multiplicity higher than 1. So what we can do is take derivatives of the polynomial, and that's something that can be done entirely in Egglog for polynomials due to the power rule. And we use the fact that the lowest n, such that the derivative evaluated, or the nth derivative evaluated at the root is the multiplicity of that root. And then we repeat this process until we've found rational roots with multiplicities summing to the degree of the polynomial. And I will show the results of running it on those 5 examples from earlier. And as you can see, it runs pretty fast. This constant polynomial doesn't get...
A little bit, sorry.
Yeah, the constant polynomial gets rewritten, but it gets rewritten to the same thing. So when we extract it, we only see this one possible example. And both of these rational examples get rewritten. So at the top of this one is, you can read that as x minus 7/3 squared times x minus 1 to the 4th times x plus 1/2 to the 1st times 3. And so that's the full factorization. And same here, this will also get factored, and these two will not be factored. They will just be extracted in their original form. So this is useful because in things like Herbie, which is a floating point optimizer, this can enable rewrite rules such as dividing out the factors of polynomials when you can prove that some terms are non-zero. And Saul will talk in a bit about how you can prove that some terms are non-zero using Egglog.
Another potential application of what we added is comparing polynomials, like checking equality. So Egglog really struggles with checking the equality of polynomials because polynomials, like in their expanded form, is just a big addition tree, and with associativity and commutativity, there is a lot of different ways to arrange that tree, and Egglog just generates an equivalence class and checks whether they are in the same equivalence class, and that equivalence class blows up for a tree exponentially. So here we have an example just of factored polynomial and then its expanded form, and checking with rewrite rules on how to expand the factored form if they're going to be equivalent. So this is just like vanilla Egglog rewrite rules, and then we also wrote it for the same form, but just using an SMT rule to basically ask an SMT solver, hey, are these equivalent, instead of generating the whole equivalence class. And yeah, if we run...
And for these two examples, they actually differ by a bit more than AC, but we'll have some benchmarks that will be shown in a bit that differ only by AC.
Yes.
And that's what our full benchmark is based on.
This, you need to expand the factored polynomial, but...
Sorry, what's AC?
Associativity and
Oh,
commutativity.
yes, okay, yeah.
So if you run the basic, you see it hangs and it takes a long time, but we don't have time for that. So if we want to check it with the SMT rules, we just check and boom, they are equivalent. So
And we
yeah,
have a check in the bottom, so if they weren't equivalent, it would
just fail, yeah. So we have another benchmark that, we have a benchmark basically that checks for expanded polynomials the equivalences, and you can see Egglog really struggles once the terms start getting bigger, or once there's more terms, it times out. Like we set the limit to 200 seconds, it could figure out for polynomials with 20 terms or greater. And yeah, this could potentially be useful if you're trying to perform some rewrites and you had a tool that would suggest, like if you're trying to, do cost extraction and you have a tool that might give you like a potentially more cost efficient polynomial, and you just want to see if you can do this rewrite without generating the entire equivalence class, you might just make an SMT query rather than make the entire equivalence class for the polynomial.
Yeah, and this is if you have potentially an unsound rewriter, so it generates candidates, but it can't actually check that they're truly equivalent.
Okay. One other thing that we did was we implemented the overflow check from lecture in Egglog. So this checks for overflow in integer addition. And in the application in class, they talked about how in their particular application, rewriting the term on the left as the expression on the right increased their efficiency in their case, and they used a term rewriting tool to do that. What we did in this demo example is we used Egglog with general rewrite rules to achieve the same purpose. So this expression, so we first defined some data types and some rewrite rules that are more general than what is used in the term rewriting framework. And we defined our original expression right here. And then we ran the rewrite rules and extracted the new expression, which was the simplified expression, and converted it to SMT here. And then over here, we defined an SMT query to check the equivalence of the original expression, the optimized expression. And the key development that integrating SMT brings us is rather than just using the basic rewrite rules in Egglog and not having a way to verify actual correctness, since Egglog doesn't encode mathematical equivalence, it's just based on the rewrite rules you define. Having an SMT query allows you to use an actual equivalence. And we have our example here. Over here, we can see the model of what the expected rewrite was. This is like the expected result. And we can see that there's no like failed check, which means the two expressions were equivalent.
All right. For the sake of time, I'm just gonna go back to work. Yeah, we had one more example, which was just a calculus example, and showed that you could basically condition a rewrite rule on an SMT check. So it showed that like if you had a rewrite rule in Egglog, if something was equal to 0, previously that was done syntactically in Egglog, like is the literal 0 there? And instead, if we use SMT to do that check, it supports more general use cases and is still sound. So that's what that shows. But just to overview, this kind of showed an example of how you can embed like a domain-specific kind of like solver inside of Egglog to handle cases that are hard to do within Egglog, but also still be modular and be used in existing pipelines. Yeah, that's so thank you all.